What we're looking at today is the last part of the basic skills, equation of a straight line. Now, what equation of a straight line based on junior school, what does that conjure up straight away in your head? Equation of a straight line is, sorry? Thank you very much. Y equals mx plus c. So, y equals mx plus c. Now, how do you draw a straight line? How do you draw a straight, that y equals, yeah, that's nice, with a ruler. What do those letters mean? Very quickly. M is gradient, C is, okay. So, notice the diagram above, y equals mx plus c. We haven't got either of those things. We haven't got that point up there. The black line, let's assume the black line's not there. We've got a point here and another point somewhere in two-dimensional space, just 2 points sitting there, and we want to create the equation. This year 9 or 10 thing, y equals mx plus c, assumes you know where it cuts the y-axis and you know what the gradient is. Okay? So what we do is we adapt this, and we're going to do the first one here, point and gradient. First of all, let us assume that the straight line has the equation y equals mx plus c, and we know that this point, x1, y1, is on that line. If the point x1, y1 is on this line, then this is in fact what we've got. We can say, well, y1 equals m. That must be true. Okay? If the point x1, y1 is on y equals mx plus c, then we must be able to substitute it into y equals mx plus c, and it must be true. Okay? So you'll see why I'm doing this in a moment. So can someone tell me what c equals? A little bit of rearrangement, subject here, subject rearrangement. What does c equals in the second equation here? y1 equals that. What? Thank you. Therefore, c equals y1 minus mx1. Okay? Straight rearrangement. So if c is equal to y1 minus mx1, I can put that y1 minus mx1 into my original equation, mx plus c, which is y1 minus mx1. And I've now got an equation. You're right. You've now got an equation which, if I move the y1 over here, just imagine the y1's disappeared, okay, a bit like this. If I've now got rid of that, factorise the right-hand side for me. There's m common, so what do? Whack that down here. It's not specific enough for me, really.
Oh, you take it out.
Yeah, what I'm trying to say is, ignore the y1. What have we got left? We've got mx and minus mx1, so let's factorise the m, and we've got that.
Why have you got x1 and y1? What's that? Why couldn't you just take, why couldn't you put the x outside as well?
Because they're different. That's an x and that's an x1. Okay? Okay. Now, so that's all I've done. I've taken the y1, moved it to the left-hand side, and what I've got left is mx and minus mx1, and the m's common, so I've just factorised it out. Now, I've just shown you that because I don't like giving you formulas that have just come out of thin air, okay? Because what this is, y equals mx plus c, it's the general formula for a straight line, but we've now adapted it, and this is the only formula that you guys get. This one here is the only coordinate geometry formula that you get on your formula sheet at the end of the year, the only one. So that distance formula, that with that square root and all the x1 minus x2 stuff, and the midpoint one, which is the averages and all that, none of that's given to you. This one is. Okay? Now, I'll show you how this works. This formula basically says if you know one point, just one coordinate, x1, y1, if you know one point and you know the gradient of the line, if you're told it, then this thing will give you the equation. Okay? As an example, try this, or watch this. Let's say we've got this, we've got a point over here, and the point is 5, 3. And we want to know what would be the equation of a line which goes through that with a gradient of a half, say, just for the hell of it. What would be the actual equation of the black line if it passes through that one point and it has a gradient of a half? Okay, that's the question. So we go back to, our formula, which is this. This is our, because y equals mx plus c is no good, because we don't know this point. We don't know where it cuts the y-axis. Okay? So y minus y1 equals mx minus x1 is the one we go to. And all we do is we substitute in what we know. We're told originally that the gradient is a half. So let's put the numbers in the right place. First of all, we say therefore y minus y1, well, we've only got x1, y1, that's 3, equals gradient x minus 5. We've simply substituted the numbers. This here is x1, y1. The gradient is a half. The x and y are just x and y. You just leave them alone. And we just substitute into our formula straight off the formula sheet. And there it is. Now, this is not the way we write equations. When we write equations, we've got a choice. We can either write y equals mx plus c sort of ones, or we write x's, y's, numbers equal 0. In other words, the general form, and I'll show you both of those now. So, what do we do here? If I doubled both sides, I'd get this. And if I put everything on the same side, writing the x's as positive, in other words, the 2y minus 6, everything going to the right-hand side, I will end up with that, and that going to the other side makes, there's the equation. What, this? That's a 0. I doubled it just to get rid of the fraction, okay? So I doubled it, got to here, and then I said, well, I'm going to move the 2y over to here to make it negative 2y. I'm going to take the negative 6, move it to the right-hand side, make it positive 6. 6 take away 5 is 1. And then I'm just going to write it x's, y's, numbers equal 0, because that's the way you write it. Okay? Now, if I didn't, this is called general form. General form. If I wanted to write it as y equals mx plus c, at this step, which is slightly too far, we've done our substitution, so I'm going to do an alternative way of writing it. I would just say, I'd expand the bracket, y minus 3 equals a half x minus 2.5, 5 over 2. I've just expanded the half into the bracket. And I'm going to take my negative 3 and put it over there. Okay, if I do that, y equals a half x, negative 2.5, add on 3, positive a half. And that is called y equals mx plus c form. And any time we find the equation of a straight line, any time, we're allowed to express the answer in either of those two forms. General, or y equals mx plus c, but not a combination. So for instance, we couldn't stop here. We couldn't just substitute it in and go, there's the equation, because that's just not enough. When we substitute it in, we have to decide, well, if we're going to write it in general form, that's what we end up with. If we're going to write it in y equals mx plus c form, then it's the bottom one, and you've got to choose. Okay? And that's that.